Okay. Dear student, please add your data plots. We need to publish in 3 minutes. Use the following Thot project. All the best. Always procrastinating. Okay, download. Okay. Let's import the project. Where is it in downloads? Experiment. Open. Okay. At least the project is already ready. Okay, so B1 is there. So I need to add my own data. Oh, it's here. Okay, so A1. 3 minutes is a long time. I should be okay. So what type is this? Noise data. Okay, so I need to add the same. Good. Okay, very good. Analyze. Okay, come on, plots. Come on, it should be here. Perfect. Just in time. And with a lot of time to spare. So this probably seemed a bit magical. I just dragged a bit of data, and lo and behold, I have my plots. So how does this happen? Well, next to a quick overview of how you will build such a project. We will only build part of it. So to build a new Thot project, we can go to the menu, we build new, we choose the folder where we want our project to be rooted, we click OK. And so this would be recipe A, for example, since we're doing part of the project that we saw before. And then click Save. So the container is the main building block of Thot. It's here that the data and the analysis lives. We'll want to add a script. So because we'll want to analyze the data. And so for the scripts, I have a predefined one. We'll use the noise stats and recipe stats. We'll explain after what exactly they're doing. So we add the scripts to the project and afterwards associate them to containers. As we saw before, we have 2 children, which we can add with a plus sign, batch 1. And we'll add the second one, batch 2. And so this is where the data will be. We'll want to associate each container with a script. So right now you can see there are no scripts. So here we will add the noise stats. And we will do the same here. And this will take our raw data and clean it. Oops, this is wrong. Noise stats. And finally, we'll add here the recipe stats, which will be comparing these two. Add. Perfect. Now we have added our scripts, and we also want to add metadata. And this is useful to linking all these things. So here we'll say this is of type batch. And then we'll give it a metadata. And these can be descriptions of the actual data, but they're also useful because we'll be able to use them programmatically when creating plots or any other sorts of analysis. We want this to be a number. This is batch 2. And we do the same here. Batch number. We add it and save. So we have batch 2 and the number of type 1. Perfect. Okay, next we want to add our data, and we can do this easily by dragging and dropping. So from before we saw the data, I have the A1, and if I open it and inspect it, it's really just an Excel file, and it could be of arbitrary shape. It could be any other sort of data as well, as long as it's a file, or even an image, which again is a file. I drag and drop, and now the way the code is written, it will check all the data that is of type noise data. So I annotate this, save, and annotate this, and save. And now we have our project set up. We have the different containers representing our project. For example, here, perhaps we were building a firework experiment. Batch 1 were all the data of the first week, batch 2 of the second week. And we want to compare these two results or aggregate them. So we've added our scripts. And now we can analyze. And as you see, instantly all the containers get populated. The way this happens is that the scripts take data in and spit data out. And so in this example, the noise stats.py will take in the original data we add, and then it gives this noise statistics. We can double click it to see what it is. And so from our previous data that we looked at, we went from the volume to simple statistics of that volume. So we can see we have the count, the mean, and the standard deviation. And then the recipe comparison script, which lives here, will take the average of these two, which we can see here. So it takes the mean and the standard deviation. And then what's very cool is simply by dragging and dropping and adding the appropriate types, we can instantly reanalyze. And all changes propagate. And perhaps a final commentary on why metadata tagging is so useful in this context is that then we can easily update our plots. If you recall, in our original plot, it said A and B, but perhaps we want to add a bit more information to it. Where is this naming pulled from? And this, so we're comparing recipe A and B, and so if we click on the recipe B container, we can see, in the metadata, this is where this information is coming from. So we could call it, for example, recipe B's, and we want to have the RB, and so we can change this to RB, for example. Maybe we want to have it then more clear. We do the same here, RB, RA. And what's great is we just click reanalyze. It will recreate all these files. We double click, and we can see that changes have been propagated instantly. And now, instead of having to manually change in different places whenever any sort of information changes, any sort of metadata data changes, you just need to click analyze, and beforehand, of course, change that information. This is Thot in a nutshell.